Good morning, everyone, and welcome to this lecture. This is lecture number 3 in magnetic effects of current, and we were dealing with Biot Savart law and magnetic field. The last thing that we did in the last class was magnetic field on the axis of a current carrying coil. We had seen the formula, we had seen the different iterations, variations of the formula. We had seen the graph of magnetic field as a function of distance. You must also remember the graph of electric field of this coil as a function of its distance. At the center, the electric field was 0, if you remember, and it was maximum at a distance of, I think, r by root 2 from the center. This is the graph for the magnetic field created by a current carrying loop. We have also seen the Helmholtz coil, which tells us which is used to create a uniform magnetic field over a short distance from one center to the other center almost. I hope you have gone through all the formulae, because with those formulae you have to solve questions, and questions are of variety of types. I will start with the question that you have with you. I think sent you the sheet and you must have gone through the questions of the sheet. Did you try the questions of the sheet?
Yes, sir.
And this is the first one. What is the magnetic field at the center O in this case? This is the question from the sheet only. First question from the sheet.
0, sir.
0. I have already discussed this question. Yes or no? You understand this?
Yes, sir.
This is the next question. What is the magnetic field at the center O? The radius is R. Option B is the correct answer. Magnetic field due to this will be 0. What will be the magnetic field due to this one?
Mu naught I by 4R, sir.
Mu naught I by 4R. What will be the direction?
Outside, sir.
What will be the field due to this wire?
Mu naught by 4 pi R, sir. Mu naught I.
Direction would be outside, and these two are going to get added up because they are in the same direction. So you have your answers. These are the questions that are coming in the exam these days. I hope one of these questions would have come in your exam as well. This is the next one. So how are we supposed to do this? Magnetic field due to this wire and this wire, they are same, yes or no?
Yes, sir.
One field is outside, the other field is inside, yes or no?
Yes, sir.
They get cancelled, only field remains is the field of this one, and it is like this, yes or no?
Yes, sir.
Do you have the sheet with you in the class?
Yes, sir.
This one. So what is the magnetic field due to this wire?
Mu naught I by 4 pi R, sir.
Mu naught I by 4 pi r. What is the direction?
Outside.
Outside. What is the field due to this wire?
That is mu naught I by 4 pi R inside.
So these two field will get.
Cancelled.
The only field that remains is the field due to quarter of a wire. How much is that?
mu naught I by 8R.
Mu naught I by 8R, that is not there in the question. So the answer is mu naught I by 8R. It's not there in the option. Misprint maybe. This one. Option C, that is correct. What is the field due to this one?
Mu naught I by 4 pi R, sir.
Mu naught I by 4 pi R. Direction?
Inside.
What is the field due to this one?
Same mu naught I by 4 pi R and inside, sir.
Then you don't have to go any further. The only option which matches is here. Remember, you have to understand that you have to do the question in the shortest possible way and in the quickest time. The field due to this one in any case is mu naught I by
4
4
pi R into
pi R
3 pi by
into
2.
3 pi by 2. And the direction is inside. Remember, you have to do the question quickly. If you can't do it quickly enough, there is no point of doing it. This one. What is the magnetic field due to this wire?
0, sir.
What is the magnetic field due to this wire?
Mu naught I by 4 pi R.
Direction?
Outside.
As soon as you get this answer, you don't have to go any further because then the only option that can match is this one. Yes or no?
Yes, sir.
In any case, what is the field due to this wire?
Mu naught I by 2 R.
In the direction?
Outside.
This one. I think our option A and outside maybe. What is the magnetic field due to this wire?
Mu naught I by 4 pi R, sir.
In the direction is
Outside.
outside. Field due to this?
Mu naught I by 4 pi R into 3 pi by 2.
Direction?
Outside, sir.
So I think the only option that matches is this one. But the direction is not inside, the direction is outside. This one. What is the magnetic field due to this one? 4 multiplied by
Mu naught I by 4
mu naught
pi
I by
4 pi A by 2
4 pi A by 2
root into root 2.
into root 2. What is the direction?
It's inside, sir.
What is the magnetic field due to this one?
4 into mu naught I by 4 pi A into root 2.
And the direction?
Outside.
What is the answer? Answer is option A. You have to be good at doing plus, minus, multiplication, and subtraction. Well, that is one thing that I can't teach you, right? Can I teach you plus, divide, multiplication, subtraction?
No, sir.
Because if we don't know that, well, not even God can save you. The Almighty God, He can't save you. He or she, regardless of the gender. This one. It is option A and
It is not tan phi, sir. It is sin phi.
take a deep breath. Relax. Close your eyes. Open them slowly. Look at the question. Look at it. Look at it closely. And then give me the answer. What is the magnetic field due to this wire?
Mu naught I by 4 pi r into 2 sin phi.
What is R?
Sir?
What is R? Radius of the circle. Isn't it? That is the R you want?
Yes, sir.
That is the R you want?
Yes, sir.
What, sir? That is the R I should put in the formula?
No, sir.
No, sir. You don't see the question correctly. You're always in a haste to get to the answer, when you should not be in a haste to get to the answer. Listen to the question. Whenever we make a formula for a diagram, that formula is only applicable when the diagram looks like the question. No, the question looks like the diagram. If there is a difference between the question and the diagram, you have to make the question according to the diagram or diagram according to the question. The formula is only valid when this distance, the perpendicular distance, is given as r. Here is the perpendicular distance given as r.
No, sir.
This is the perpendicular distance that you have to find out. And that is r cos phi. So now what is the magnetic field due to this wire?
It is option A, sir.
It is option A. You need to take deep breaths. You need to take deep breaths. Deep breaths. Between the direction is not asked. In any case, the direction would be inside. The magnetic field due to this wire is mu naught I by 4 pi r into 2
pi
pi
minus 2.
minus 2 phi. Be careful when you are putting a formula. Do not do it in haste. Otherwise, you will end up with a lot of negative marks. Remember, one negative mark is not one negative mark. It's 5 negative marks from where I see. My calculation is a bit different. And my calculation is very simple. If you get -1 in any question, you do not get -1. You get -1 for wrong And plus 4, you also lose. Because if that question should be right, because you attempted it. You attempt a question only when you feel that you are going to get the right answer. Otherwise, you don't attempt it. So you don't get -1. You get -1, -4. You get -5 if you mark any question wrong. But my calculation is different. If you get it wrong, you get -5. If you get it right, you get +4. So ultimately, if you get one question wrong, according to my calculation, you get -9. My calculation says one question wrong is -9. Cannot get a question wrong. Remember, to get to 99 percentile in JEE Main, overall 99 percentile in JEE Main, you need somewhere around 130 to 140 marks. That will get you to 99 percentile almost. To get 130 or 140 marks, you only need 40 to 50 marks in physics. To get to 40 and 50 marks in physics, assuming that you are getting all 40s and 50s in all the three subject, you only need to do 15 questions correct. 15 into 4 is going to get you to 60. You just need to do 15 questions. Remember, whenever you see the paper of 30 questions, you are only supposed to attempt 15 of them. That's it. That's it. That is your upper side. You are not supposed to solve 25 questions or 30 questions. You're only supposed to solve 25 questions. You're only supposed to solve 15 questions. That's it. No more than that. That is your aim. And none of them should be wrong. You get to 60 marks. If you apply the same strategy in physics, chemistry, and maths, you will get to 180 marks. And that will give you to 99.5 and 99.95. And one question wrong, you get -9. This is the next one. So don't be in a haste. We are not talking about speed in your case. We are only talking about correct answers in your case. Take your time. You only have to solve 15 questions in 1 hour, 4 minutes per question. That's it. That's your upper side. Not more than that. Don't even think of doing more than that unless and until you are imagining that I am going to get 0 in maths or 0 in chemistry. If you are thinking that you are going to get 0 in maths and 0 in chemistry, then only you solve more than 15 questions in physics. Otherwise, you don't do it. And if you are not able to solve any question in maths, then you save that time for maths and then you come back to physics. 15 question is what you are going to solve. The first subject that you are going to attempt will be chemistry. Then it has to be physics. Then it has to be maths. That is how you should go about it. Chalo, this one. What is the answer for this one? Remember, only 15 question is your higher limit in any subject. Chemistry may be more, but in physics but in physics it cannot be more than 15 questions. You are not going to solve more than 15 questions in the examination hall, no matter what happens. The magnetic field has to be inside, so option B and D are already gone. Because of this wire, it will be mu naught I by 4 pi A into 3 pi by 2. The only option that matches is this one. That is the correct option. Do we understand this?
Yes.
Now remember, as I told you, and I will keep on insisting the fact, you're only supposed to solve 15 questions, and I'm just taking the example of this paper. This is a paper this year, 31st. Just got this random paper, I think morning or evening. You just have to suppose to solve 15 questions in physics. You can solve question number 1. It is just a matter of I'll be telling you. I told you that in the class for the other students, the uses of ultraviolet. One question number one. Question number two, adiabatic process. You can do it in less than 5 seconds. Question number three, ratio of maximum height of balls. You can do it in 5 seconds. I think this was the paper some of you attempted probably. Question number four is the easiest question in the entire universe. Four. Question number five, easiest question in the entire universe. You just have to make that equation. We have done too many questions. Question number six, easiest question in the entire universe. Question number seven, too many questions we have done on this type. Question number eight, sum of height received by the projectile. I've given you everything that you needed to know. Question number nine, G on the surface of Earth. Easiest question in the entire universe. Question number 10, this is the question of magnetic field. See, this is the question of magnetic field due to a wire. A wire is called into n circular terms. We will do it now. Young's modulus we have not done, so forget about this. But this is only the speed of sound. We have done speed of sound. Yes or no?
Yes, sir.
11. 11 question. Same heat produced in resistance. 12. Inductor AC we have not done. Forget about it. Optics we have not done. Forget about this. Percentage change in voltage sensitivity. I have done voltage sensitivity. Yes or no?
Yes, sir.
Question, how much? Question number 12. Other questions are not there. Forget about this. We have done 12 questions. This we have not done. Forget about this. This question, same question we had done in the class. Question number 12. Question number 13. This is question number 14. I'd given you the formula of this. Question number 15. I've solved question 15. That's it. That's it. And did this solving this question should not take more than 16 more than 30 minutes. That's it. You're done. Physics is done. That is only doing the questions that topics that we have done up till now. That is much more than enough because the other questions are not present at all. 4 questions, 5 questions are missing from this section. 5 questions were missing from that section. Even then, you were able to solve the entire paper without even doing almost 1/3 of the course. So remember, you don't have to solve more than 15 questions in any case. But do not make mistakes. You are making a hell lot of mistakes in doing simple questions. Not advisable. Cannot be done. You'll not be able to clear JEE no matter what happens. Be careful. You're not going to solve 20 questions. Even if I said I will not be able to solve it at my speed. So only 15 questions you have to solve. That will get you to 99.5 percentile. That is much more than enough for you to get any decent NIT of your choice. This is the next one. What is the magnetic field at the center? Magnetic field due to this wire is 0. Magnetic field due to this wire is 0. And we can understand all the magnetic fields are getting added up. Yes or no?
Yes, sir.
Pakka na?
Yes, sir.
And all the magnetic fields are going in the inward direction. Yes or no? Yes or no?
Yes, sir.
All the magnetic fields are getting added up and all the magnetic fields are going in the
Inside.
That's it. I don't need to look at anything. That is the answer. I did not solve anything and I still got the answer. Do you understand?
Yes, sir.
How do you use common sense? All the fields are inside and all the fields are getting added up. I look at the options and this is the option. This is the only option which has that. I don't need to solve it. Unless until there are other options which are similar. I don't have to solve the question. I'm done with the answer. And remember, the options are given in this way. This one. Again, the magnetic field is going to go outside. It is going to go outside for all the 3 wires. Yes or no?
Yes, sir.
And all the three wires, they are getting added up. We don't have to go any further because you will just mark the answer on that basis. You can see life is as easy as it gets, as difficult as you make it. This one. Magnetic field due to this wire is how much?
Mu naught I by 4 pi A into theta, sir.
And the direction?
Outside.
Magnetic field due to this wire is?
Mu naught I by 4 pi B into theta.
Direction is?
Inside.
So as you can see, the fields are going to get subtracted. So this option and this option definitely go away.
Yes, sir.
Which field will be more? The outer one or the inner one?
Inner one, sir.
That's it. So the correct answer is this one. Do you understand this?
Yes, sir.
This one now. Something has changed. Current is coming from inside the board onto the board, moving on the board, then going like this, then going like this. Give you 2 minutes to give me the answer. So how are we supposed to solve this? I given you enough time. Magnetic field due to this wire is 0. What is the magnetic field due to this wire?
Mu naught I by 4 pi into 3A by 2 into pi, sir.
In the direction?
Inside.
What is the magnetic field due to this wire?
Sir, it is outside, sir.
Outside. What is the magnetic field due to this wire?
Mu naught I by 4 pi into A by 2 into pi, and it is inside.
So the okay. So the net magnetic field that will remain will be how much? Between these two? Anyways, what is the magnetic field to this wire?
Sir, it is mu naught I by 4 pi into 3A by 2 cos theta into 1 minus sin theta.
Huh? Cos theta, sin theta? Huh? Don't know what you're saying. The distance is this much, 3a by 2. It is a semi-infinite wire. It is coming from the z-axis. I don't know whether you understood this or not. That is why the z-axis is given. It is coming from inside of the board. So if I look at this question is like this. The wire is coming like this onto the board. Then it turns like this, ding. Then it goes like this, ding. And it turns like this, ding. And then it comes out. So this is a semi-infinite wire, mu naught I by 4 pi into 3a by 2. And the direction would be downwards. Downwards means minus j axis. The magnetic field to this wire will be mu naught I by 4 pi into a by 2 The direction will also be inside. Do we understand this?
Yes, sir.
In fact, you do not have to do so much. Looking at the option, I can tell you which is the answer. Both the fields are perpendicular, so this negative sign in between cannot come. Yes or no?
Yes, sir.
The only options could be B and C. Looking at option C, you can understand that this is dimensionally wrong. The only option has to be option B. There is no other option which is possible. You have to be smart enough. If you're not smart enough, you will lose a lot of time. That is why I gave you so much of time. You took 10 minutes and still you are looking here and there. Only by just seeing the direction you could have told me the answer. So direction is inside, outside, and up, down. So the fields are perpendicular. So there should be a positive sign in between. And the C option is dimensionally wrong, sir. So this goes out. Don't have to solve anything. But then you have to use your brain. And using brain is strictly prohibited in physics. You should not use your brain. Strictly prohibited. Why should I use brain? Why should I use brain? No, there's no need of using brain. This is the next one. The wires are going in different planes. The magnetic field due to this wire, where will it go?
Sir, what is sir? It is along positive y-axis. Sir. No, sir. Sorry, negative x-axis.
This is going along negative x-axis. Where is the magnetic field of this wire going?
It is positive y-axis. Sir, negative y-axis.
It is going inside negative y-axis. Both are perpendicular. The only option has to be this one. There's no other option possible. Do we understand this? Or this has gone above our head saying bye bye?
Understood, sir.
Magnetic field to this wire?
Sir, it is in the positive y direction.
Outside. Magnetic field to this wire? They are adding up, yes or no?
Yes, sir.
What is the direction?
Z.
Though I must admit that this x, y, and z axes are not correct. These x, y, and z axes are not correct. This has to be minus y. This cannot be plus y. X, y, and z axes are incorrect. Anyways, both these fields are perpendicular. Yes or no?
Yes, sir.
Only option has to be this one. There's no other option possible. Do we understand this? Or this has gone above our head saying bye bye? Bye bye. I'm going, sir. Bye bye. I'm going. Bye bye.
Understood, sir.
This one. Option B is correct. What is the magnetic field at the center of this rotating thing? Mu naught by 4 pi into Q into V by R square. Yes or no?
Yes, sir.
V. What was V?
Omega by r equals to 2 pi, sir.
Mu naught into Q into omega by 4 pi R. Yes or no?
Yes, sir.
And this omega is 2 pi into F. Mu naught Q into 2 pi into frequency F divided by 4 pi R. Yes or no?
Yes, sir.
This is the formula, and that is equal to, you have to just find the answer for this one. I think the answer that you are getting is this one. We get this?
Yes, sir.
This one is the next one. Option A is correct. We have already given this relation. Oops. Magnetic field at the center divided by magnetic field at any point on the axis will be given by which formula?
1 plus x square by r square and whole power 3 by 2.
Your x is 3r and r is r. You put the values and I think you will get the answer as 10 root 10, not 20 root 10. Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
This one then. The last one in this category. Then we'll move ahead. Two infinite length wires carry current 4A and 6A respectively and place along x and y axis. Magnetic field at the point 0, 0, D is. So if I just show you the diagram, I think this question would be solved. The diagram looks like this. This is the original diagram, that original axis. Your x-axis would be here, your positive y-axis would be here, and your positive z-axis would be here. Yes or no?
Yes.
Magnetic field due to this wire, infinite wire, would be in this direction. Do we understand this?
Yes, sir.
Magnetic field due to this wire would be in this direction. Both the values are same. No, currents are different, so the values are different, right? This magnetic field is mu naught into current is 8 ampere.
Yes.
Divided by 2 pi into D. Yes or no?
Yes, sir.
Magnetic field due to this wire is mu naught I by mu naught into 6 divided by 2 pi D. Yes or no?
Yes, sir.
Both these fields are perpendicular, so they will get squared and added up. Yes or no?
Yes, sir.
Okay. This finishes this part of this chapter. I'll give you 5 minutes. Go through all this formula once again. Once again, go through all this, and we will start with the next part. Revise all this formulae. See any question that you have not understood. If there's anything that you have not understood, let me know. Then let's move ahead into the next heading, and the next heading is this one, Ampere's circuital law. Ampere's circuital law. Have you heard about this Ampere's circuital law? No one? Suppose I have a closed loop. This is a closed loop. and I move in this closed loop one round, then Ampere circuital law simply states that the line integral of magnetic field, the line integral of magnetic field through this closed loop is equal to mu naught times the current enclosed in the loop. Mu naught times the current enclosed in the loop. Now, this I only includes the current which is coming inside the loop, but this magnetic field is the net magnetic field due to all the currents produced present everywhere in this universe. Does this remind you of something that we have already done? It does not remind you of anything. This is somewhat similar to Gauss' law of electrostatics. There it was surface integral of electric field over a closed surface is charge enclosed by the surface divided by epsilon naught integral of E dot ds. Is charge enclosed by the surface divided by epsilon naught. Here it is the line integral of magnetic field over a closed loop is equal to current enclosed by the loop divided by epsilon naught. So this is somewhat similar to the Gauss law in electrostatics that was written as surface integral. This is written as line integral. Here, if the charge were positive, they were taken as positive. If the charge were negative, it was taken as negative. How do you take current positive and negative here? So you look at the direction in which you are moving in the loop. If you are moving in the anti-clockwise direction, outward charges will be taken as positive and inward charges would be taken as negative. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Now remember this Ampere's law. It does not depend on the size and shape of the loop, closed path. It can be in any size, any shape. Any current outside the closed path is not included. The same as any charge which is coming outside the surface will not be included. The statement line integral of this is 0 does not mean that B is 0. It only means that there is no net current in the path. Do we understand this? It's the same as saying flux is 0. That does not mean that electric field is 0. It only means that the net charge inside that surface is 0. Do we understand this?
Yes.
Give you 2 minutes to note this down. Okay, then this is a small question so that you understand how to apply this. Calculate the value of integral of V dot dl for L1, L2 and L3. 3 closed loops have been drawn. You have to tell me the answer for this one. I'll give you 2 minutes to solve it. What is the line integral of this one for this loop?
I1 minus I2 into mu naught.
I1 minus I2 into mu naught. That is correct. What is the integral for this loop?
I1 minus I2 plus I4 into mu naught.
I1 minus I2 plus I4 divided by mu naught. What is the integral for this loop?
0.
So do we understand how to carry out this integral?
Yes, sir.
Now you can use this Ampere circuital law to find the magnetic field due to symmetrical current distributions. For example, you can find it out. You can use this Ampere circuital law to find out the magnetic field due to an infinite wire. Do we understand this?
Yes.
Similar to, you can use Gauss theorem to find out electric field due to spherical charges, infinite charges and all those. You can use this Ampere circuital law to find out the magnetic field due to uh, some symmetrical charge distributions. And the first one, we already know the answer for this one, but again we'll just go through it so that we understand how this Ampere circuital law is used. So now you can see this. You have a current carrying wire, infinite. Remember, it can only be used for infinite wire, semi-infinite wire, or any other wire which is bent. It cannot be used. This is a this is an infinite wire. We have to find the magnetic field at this point P. We know that this magnetic field is moving in circles. Yes or no?
Yes.
At all the points on this circle, this magnetic field will be same in magnitude. Yes or no?
Yes.
Different in direction. So we have drawn this top view of this wire. Do you understand top view?
Yes.
So the magnetic field will be looking like this. Yes or no?
Yes.
The magnetic field will be moving in circles. Yes or no?
Yes, sir.
Integral of B dot dl will be equal to B into integral of dl will be equal to B into 2 pi r. Yes or no?
Yes, sir.
And this should be equal to mu naught into I. From here you can find out that the magnetic field due to an infinite wire can be found out using Ampere circuital law. Do we understand this?
Yes.
I'll give you 1 minute to quickly note it down so that you understand how this Ampere circuital law is applied. The next one is an infinite hollow cylinder, and in an infinite hollow cylinder you can see the current is only on the circumference of the cylinder. Do we see this?
Yes.
Magnetic field at any point inside, that means your distance r is less than your radius of the circle capital R. How much will be the magnetic field at any point inside this?
0.
Magnetic field on the circumference, on the surface. Let me not call circumference, let me call it as surface. How much? It will be the maximum, and that will be equal to mu naught I by
2
2
pi.
pi capital R. Magnetic field outside, where R is greater than capital R, will be how much? Mu naught I by 2 pi R. Does this remind you of something that we have already done?
Yes, sir.
This is the graph, and again this graph has come, whether it's a graph where we have done something similar like this.
Electric field
Due to what?
due to hollow sphere.
Or conducting sphere, similar formulae, similar graph. Do you understand this, or this is going above our head saying bye bye? I'm going bye, I'm going bye, I'm going bye.
Understood, sir.
Then from hollow cylinder we will move to a solid, infinite solid cylinder, and now the magnetic field will not be zero inside. Do we understand this?
Yes.
In fact, you can see this magnetic field B will be directly proportional to R. Does it remind you of something?
Yes, sir.
What?
Uh, Electric field inside solid non-conducting sphere.
Similar formulae, I have also given you the vector form. At which point is the magnetic field maximum? Where is the maximum magnetic field maximum? It is maximum on the surface. This is the vector form of the magnetic field. If you want to write it in the vector form, you can write it in the vector form. This is the scalar form. This is the vector form for outside. You can write in different ways. I'll give you time to note it down. Then we have thick cylinder. What do you mean by thick cylinder? It has inner radius A and outer radius B. Do you understand this?
Yes, sir.
Inner radius A, outer radius B. If I go to a point which is less than A, the magnetic field will be zero. Yes or no?
Yes, sir.
On the axis of the cylinder also magnetic field is 0. Yes or no?
Yes, sir.
At a point between the two, we can easily find out the magnetic field will be given by this formula. R square minus A square divided by B square minus A square, outer minus inner. Now, you can remember it in any ways. At the inner surface, the magnetic field will be 0, and at the outer surface, magnetic field is maximum. Do we understand this? Do we understand this?
Yes, sir.
At any point outside, the magnetic field will be same as the other cases. Everyone understands this?
Yes, sir.
2 minutes to note this down. And you can see the same thing in column-wise fashion. The first cylinder is solid. The second one is thin hollow. The third one is thick hollow. In all the above cases, magnetic field outside the wire, outside this cylinder is mu naught I by
2 pi r.
2 pi small r, and on the surface it is mu naught I by 2 pi capital R. Do we understand this?
Yes, sir.
In all the three cases, the magnetic field inside the cylinder, when there is no material, it is 0. When there is material, it is not 0. Do we understand this?
Yes, sir.
Do you want to note this down?
Yes, sir.
Okay, do it fast. Then we can note down the value of magnetic field for a solid cylinder. Inside the cylinder, I had given you all these formulas, yes or no?
Yes, sir.
For a cylindrical shell, at any point in between, the magnetic field is mu naught I by 2 pi r square minus small radius square divided by bigger radius square minus smaller radius square. Do you understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
I'll give you 2 minutes to note this down if you want to. So this is the question, solve it. So how are we supposed to do this? In first case, what will be the answer?
Sir, in first case, it is mu naught I into x by 2 pi r square a square, sir.
Mu naught I naught x by 2 pi a square. Yes or no?
Yes, sir.
Now in the second case, the magnetic field due to inner wire will be mu naught I by 2 pi x. Yes or no?
Sir, mu naught or b naught, sir.
Oh, mu naught.
Okay, sir.
And if this current is outward, if this current will be outward, it will be moving anti-clockwise. Yes or no?
Yes, sir.
And due to the outer shell, it will be 0. Yes or no?
Yes, sir.
In the third case, magnetic field due to this wire. Remember, this is carrying current in the outward direction. This is carrying current in the inward direction. Due to this wire, it will be mu naught
I by
I
2
naught
pi
by 2 pi x. Mu naught I naught by 2 pi x. If it will be anti-clockwise, the other field will be clockwise, and you have to put the formula of that one. Mu naught I naught by 2 pi x into x square minus b square,
c square into c
b
square minus,
square minus c square. Yes or no?
sir, c square minus b square.
Yeah, c square minus b square. Got this?
Yes, sir.
In the fourth case, it will be 0 because both the fields will cancel out each other. Yes or no?
Yes, sir.
That is the answer in this case. Let us move on to the next portion. Magnetic field due to an infinite sheet. magnetic field due to an infinite sheet. So basically your sheet is going to be infinite. When I say infinite, it will be infinite in 2 dimensions. Do we understand this?
Yes, sir.
In this case, the field is infinite. In this dimension, it is infinite, and it is infinite in this dimension. Do we understand this?
Yes, sir.
Now, this sheet, if I show you a different view, you can draw this sheet like this. Do we understand this?
Yes, sir.
Now, if I show you another view, I can show you the side view of the sheet, and the side view of the sheet would look like this. It should come here. The side view of the sheet would look like this. What I have drawn here is the sheet carries current in this direction. Do you understand this? The sheet carries current in the inside direction. It is infinite in inside direction. It is infinite in this direction. If you take any point here, the field will be going in this direction. If you take any point here, see, current is going inside. Magnetic field will be pointing here. Do we understand this?
Yes, sir.
Okay, the diagram is wrong, so I'll just take that diagram off. Show you a different diagram here. If I have the diagram, it becomes easy. Yes, this one is better. So if I show you this diagram, magnetic field at the points which are above would be in this direction, and magnetic field at the point which are below will be in this direction. Do we understand this? Current is going inside. Magnetic field at above points will be in this direction. Magnetic field at below points will be in this direction. Do we get this?
Yes, sir.
The value of this magnetic field B is given by mu naught into lambda by 2. Where what is this lambda? This lambda is current per unit length of this sheet. Current per unit length of the sheet. Current per unit length. And this is the only type of distribution which creates a uniform magnetic field. Now this formula should remind you of something that we have already done. Which formula it reminds you? Which formula should it remind you? Electric field due to an infinite sheet. I know that you have forgotten this formula. Anyways, sigma by 2 epsilon naught was the formula of electric field for an infinite sheet. When it becomes infinite sheet carrying a current, the formula becomes mu naught lambda by 2. Mu naught in the numerator, epsilon naught is in the denominator. Here it is sigma, here it is lambda. Formula is same. I'll give you 2 minutes to note this down. Then you have this question. You have two infinite sheets, each having current per unit length as lambda. Both of the sheets are carrying current in the inside direction. You have to find magnetic field at 3 points A, B, and C. They are very close to the sheet. I'll give you 2 minutes to give me the answer. What are the answers for this one?
Sir, if I consider positive x like positive x-axis as positive direction, at point A it is mu naught lambda.
At point
B,
A, it will be going in this direction. It will be equal to mu naught into lambda due to Lambda by 2 due to 1, lambda by 2 due to 2. They will get added up. At point B,
0, sir.
at point C,
Point C in the opposite direction, it is mu naught
do
lambda.
we understand this?
Yes, sir.
The next heading that we are going to write is solenoid. Solenoid. Magnetic field due to a solenoid. I already told you what is a solenoid. Yes or no? Yes or no? Do we know what is a solenoid?
Yes.
A solenoid looks like this. It carries current. And let us see, the current is going in this direction. This is the axis of the solenoid. If the current is going like this, you can represent it in this fashion also. From here it is coming out and here it is going in. Do you understand this?
Yes, sir.
The magnetic field due to a solenoid, if you see the direction, the magnetic field actually goes like this. Do we understand this?
Yes, sir.
Current is coming outwards from one side, from the top, and current is going inside from the bottom. Do we understand this?
Yes,
Do you
sir.
understand the direction of current and the direction of magnetic field? Do we understand this?
Yes, sir.
Okay, this is a solenoid. Now, if I can draw the solenoid like this, and if I call the two angles at alpha and beta, if you don't want to call it as alpha and beta, you can call them as theta 1 and theta 2. The magnetic field inside at any point P will be given by this formula, mu naught Ni by mu naught Ni by 2 into sine of alpha plus sine of beta. Does this formula look similar?
Yes, sir.
This is similar to magnetic field due to a wire. Yes or no?
Yes, sir.
Here n is the number of turns per unit length. It has got a large number of turns. N is the number of turns per unit length. Do we understand this?
Yes, sir.
This is the magnetic field due to a solenoid. I'll give you 2 minutes to note this down. Then you can note down the formula for magnetic field due to an infinite solenoid. Both the angles will become 90 and 90. Yes or no? It will become mu naught Ni. If the solenoid is of infinite length and the point is near one end, that means it is semi-infinite. Do we understand this?
Yes.
The formula becomes on the end of the solenoid mu naught Ni by 2. One angle is 0, the other angle is 90. Do we understand this?
Yes, sir.
Outside the solenoid, the magnetic field is taken as 0 at any point inside. It is mu naught Ni. At any point on the end, it is mu naught Ni by 2. I'll give you 2 minutes to note this down. Then we move on to the last heading of this particular section. Magnetic field due to a toroid. What is a toroid? As I told you, toroid is just like the tube of your scooter or your car tire. It's a cylinder and you make this cylinder into a round shape and then you have a wire onto it. Do we understand this? This is a toroid. If n is the number of turns in the toroid, remember at any point here in section A, the magnetic field is 0. At any point here, the magnetic field is still 0. Magnetic field only exists inside the internal space of the toroid, and the magnetic field inside the internal space of the toroid along the axis of the toroid is given by this formula, B is equal to mu naught Ni by 2 pi r, where n is the number of turns of the toroid. If you write it as small n is capital N divided by 2 pi r. Sometimes people call it the number of turns per unit length of the toroid. The formula starts to look similar to the formula of an infinite cylinder. Do we understand this? In all these spaces here or here, the magnetic field is 0. Do we understand this? I'll give you 2 minutes to note this down. Once you are done, please tell me. Then this is first question. A long solenoid, whenever they say long or ideal, it is an infinite solenoid. A long solenoid has 200 turns per centimeter, carries a current of 2.5 amperes. What is the magnetic field at the center? I'll give you 2 minutes to give me the answer. Option B is the correct answer. Remember, for a solenoid, the magnetic field inside the solenoid is mu naught Ni. And remember, this is the number of turns in SI unit, per unit length in SI unit. So it should be number of turns per meter. Do we understand this?
Yes, sir.
If you remember this, if you understand this, then it is great. Mu naught is 4 pi into 10 raised to the power of minus 7 into 200 turns per centimeter. So per meter, it will become this much. Yes or no?
Yes, sir.
Divided by 100 or
No, sir.
multiplied by 100?
Divided by 1 by 100, that is multiplied by 100. Sir.
Correct. So don't make this mistake. Multiplied by 100, multiplied by 2.5. If you do it correctly, you should end up with, sorry, option B. It is multiplied by 2. Yes or no?
Yes, sir.
Anyone got this?
Yes, sir.
This is the next one. Do it fast. So the magnetic field inside a solenoid is mu naught and I. Magnetic field is given as 20 millitesla, 20 into 10 raised to the power minus 3. That must be equal to mu naught 4 pi into 10 raised to the power minus 7. 20 turns per centimeter is 20 into 100 turns per meter into the current I. Forget about this all these units, because units do not make much of a difference. 2 and 2 will get cancelled. So answer will be 1 by 4 pi, 1 by 3.14, and the answer would be 1 by 4. So answer is 1 by 4 pi, somewhere approximate to 1 by 4 pi. I don't know how you are getting this. The calculations, your calculating skills are worse than a student in second standard. And you must drastically improve on them. Because if you don't, physics is not going to help you out. And the calculations that you are not able to do, I even call it maths, because that is not maths even. You cannot multiply and divide, and I don't know. My son can do better multiplication and division than you guys. He knows a table till 17, and if I ask you 14 sevens are, you will not be able to tell me. So he's better. He's in standard 2. Anyways, this is the next question. Two solenoids having length L and 2L, number of loops N and 4N, both have the same current, then the ratio of magnetic fields will be how much? Give you 2 minutes to solve this. Option A is correct. B is equal to mu naught and I. Mu naught and N are same. So B is directly proportional to number of turns N by L. So B1 by B2 will be equal to N1 by N2 into L2 by L1. If you do it correctly, which I am not very confident, the answer would be 1 by 2. The only two things that you have to do is you need to understand and practice multiplication, division, addition, and subtraction. The second thing you got to do is to remember that you remember something. And the only thing you have to forget is to forget the habit of forgetting things. If you can do these three things put together, no one in this universe can stop your selection. If you fail to do any one of these things, No one in the universe can make you select into an IIT. So it's both ways. If you can do all these three things together, first thing, multiply, add, divide, subtract correctly. Number two, remember things. Number three, forget the habit of forgetting things. Do these three things, nothing in this universe is stopping you from getting into an IIT or an IIT of your choice. If you fail to do any one of this, no power in this universe is going to get you into any IIT or any NIIT this year or the coming year or throughout your life. So this is the last chance you have, my dear friends. Last mocha. Last question for today's class. And this is this one. Multiply, divide, plus, addition, subtraction. Remember things. Forget the habit of forgetting things. So what is the answer for this question? Magnetic field due to a toroid is mu naught Ni by 2 pi r. Yes or no? You just have to put the values, get the answer, and stay happy. And that is the most difficult thing, because you have problems in multiplication and division. Yes. Answer? Four pi into 10 raised to the power minus 7. Total number of turns 500. Current is 0.5.
Sir, option D.
You see, God exists. If you just pay a little bit of attention into multiplication, division, addition, and subtraction, nothing can stop you, as I told you. So remember these small things. Whatever formula I have given, I hope you are making shortcuts of that, putting it in a single sheet of paper. Every formula, for example, whatever formula we have done in this chapter should be on a single sheet of paper, so that whenever you want to revise, you can just look at those formula and go ahead in life. I hope you are doing it, because in the end, if you want to revise, you cannot revise it from even your notes, because it is just too much. Keep those simple things ready, handy in your cheat sheet. I used to call it cheat sheet. Look at this page and you are done. So I'll wind up this class here. Magnetic field as such is done. We have covered everything that can possibly come in this exam or any exam that you're going to face in your near future. Next class, we'll start with magnetic force and try to wind it up. Time is running very fast, so I'll try to wind it up. Remember, practice questions. You do not need to practice question. I think you need to practice calculation. So practice calculation and remember things. If you can't remember them, always make a big what you call collage. Put all those formulas together, and every time just keep on seeing them. Keep on seeing them. Keep on seeing them. There was a famous poet, I think Kabir. He said, "Karat karat abhyas ke jadmati ho sujan." That means if you keep on practicing, even jadmati means those who does not have any buddhi can become sujan. Sujan means intelligent, and that is what Kabir Das has said, and he is definitely more intelligent than I and you. So I believe that he has said whatever he felt was correct, and is definitely correct. You keep on looking at one thing, you will become good at that. On that glorious note, I will wind up this class. I hope you have understood, and you would be able to recollect it and reproduce it 2 months from now. You see, even not 2 months, because today is 14th of Feb, and your exam is somewhere around 6th of April. Not even 2 months. Take care. God bless all of you. Bye bye.